Welcome to another lecture on construction safety, and today we're going to talk about theories of accident causation. Why do accidents happen? And why do they tend to happen more to some people rather than others? And why do they happen more on certain jobs rather than others? And so on. So we're trying to find a systematic way of identifying the reasons and the root causes of accidents happening. This is basically the topic of this lecture. The first theory is called the Domino Theory, and as you can imagine with the dominoes, once you flip the first one, it triggers what's called a domino effect. It falls on the following one and the following one and so on, and all the pieces tend to fall. So the idea from the domino theory is that once we identify the root cause of the problem, if we can eliminate that, then all the following events are not going to happen. So by removing the unsafe acts and the mechanical or physical hazards, accidents and therefore injuries can be avoided. That's the basic premise of that theory. So it says, if you have a cause, like for example, ancestry and social environment, people who have been raised in an environment not paying attention to certain hazards, not knowing about these hazards, or practicing something that's hazardous in itself that can cause more risks. So this is the primary cause. The effects might be fault of person who might make a mistake because they wouldn't know that this is a risky behavior, which might result also in another effect, unsafe acts and mechanical or physical hazards, causing these physical hazards for themselves and for others. Effect number 3, an accident. Effect number 4, an injury. So if we can eliminate the very first one, the cause, none of these effects is going to happen, and this is the first theory, which is called, as it appears from its name, the Domino Theory. The second theory is called the human error theory, and it says that the human errors occur due to either overload, you're overloaded with too many things, you cannot multitask, and people in general cannot multitask. Very few can successfully multitask. So if you try to do too many things at the same time, or if you are pressed on time and trying to achieve more, that might lead to accidents. The other one is inappropriate response. So for example, there was a loud noise and you just did something, you moved in a certain direction or something like that, which might cause an accident or an incident. And inappropriate activities that you should not be doing in the first place. You are not trained, you are not qualified to do this activity, but you volunteer to do it, so that might result in an accident or an incident, and all of that is due to a human error. A slight modification of the human error theory is the human factors theory, which again looks at the same 3 issues: the overload, inappropriate response, and inappropriate activities. So the overload could be environmental factors like noise or distractions. You're doing a job while you're distracted by a side conversation or something like that. Internal factors like personal problems or emotional stress, stress at work, stress at home. Or situational factors, unclear instructions. You are given a certain task without having the proper preparation for that task, without having clear instructions on how to perform it, and that might result in a higher risk level for that particular individual who is not trained to do this job properly. So all of that would fall under overload. Inappropriate response, detecting a hazard but not correcting it. If you see something wrong on site and you say, that's not my job, I'm not responsible for it, I did not cause it in the first place, so I'm not going to correct it, that by itself is an inappropriate response. Removing safeguards from machines and equipment. Sometimes a piece of equipment would have a safeguard or a shield to protect the user from sparks or from blades, sharp blades or things like that. And you might think, this is impeding my work, this is slowing my performance, reducing my productivity, so I'm going to remove that shield. Or for example, you're working on a high platform and you say that safety harness is impeding my motion. I cannot move freely wearing that safety harness, so I'm going to take it off. That's exactly when the accident happens. Or ignoring safety. The safety instructions say that you have to wear a hard hat on site. You have to wear goggles. You have to wear boots with steel toe, for example. and you ignore these instructions, that will result in an accident. The third one is inappropriate activities. Examples include performing tasks without the requisite training. Again, if you're not trained, do not do it. Or misjudging the degree of risk involved with a given task. And this especially happens to people who have done this task so many times in the past. They would say, well, I've done this task 100 times in the past. It's not going to happen to me. It happens to other people. So in fact, this is a problem that happens to people with a high level of experience, when they let their guards down and they do not pay attention to the routine steps to be followed to have a safe work environment. So this is the human factors theory. Another theory is called the accident/incident theory. So the accident/incident theory says that, again, some reasons could be because of overload, pressure, fatigue. By the end of the day, you're tired. Motivation, you are motivated if you do it in a shorter time, or if you achieve more, if you have a higher productivity, you're going to be rewarded. So again, you try to achieve more at the expense of safety. Drugs, alcohol, or worry. Drugs and alcohol, definitely there's no tolerance, zero tolerance of drugs and alcohol on construction sites because of the direct correlation between these and accidents. So we try to avoid them from the very first place. So all of these are one of the reasons that cause accidents and incidents. Another one is ergonomic traps. Incompatible workstation tools. There are some injuries that occur to certain vocational workers on site due to a bad analysis of the operation itself. You're going to carry something, for example, you're going to carry something heavy and you're not carrying it properly, or you do not wear a belt or something to support that weight, or it should be carried by two people and they try to carry it by itself. So this is an ergonomic trap through incompatible workstation tools. Even people who are doing office jobs, you notice that if they type too much during the day, they might get the carpal tunnel syndrome, and they might need surgery to fix that. So again, with the proper posture, with the proper location of the different pieces of equipment, you can avoid these accidents. Incompatible expectations. Again, the example that I just gave about something to be carried by more than one person and one person only stepping forward to carry it is going to result usually in an injury. The third one is a decision to err. Does anyone make an educated decision to err, to make a mistake? Not necessarily educated decision, but it might in some cases be an intentional decision to do something that's dangerous, thinking that I'm too good for that accident to happen to me. I know better, I've experienced it, I've done it in the past, so the accident will not happen to me. And that can result either from misjudgment of the risk, by thinking that, oh, I know how to deal with that risk. Unconscious decision to err. I'm hasty, I try to do it faster than usual. Logical decision based on the situation. Actually, it should be even an illogical decision, because if you applied logic and if you thought thoroughly about it, you would say, no, I shouldn't do that. An example of the decision to err is to remove your safety harness while working on a high platform, for example. What's going to happen in this case? You might be subject or you might subject to falling and getting a severe injury. All of these lead to human errors, going back to the human error theory. Or system failure. Another reason causing the accident incident theory is the system failure. Either the policy is defective, the safety policy is defective, or responsibilities. You are not assigning the proper responsibility. You do not have a competent person on site. You do not have a safety officer to enforce all of these policies. Training, lack of training, for example. You introduce a new piece of equipment and you ask your employees, your labor, to work with it immediately without giving them the proper training. That usually results in accidents. Inspection. The fire extinguishers have to be inspected on a regular basis. You did not inspect them properly. They were used previously without refill or without replacement. So in this case, the inspection or lack of inspection is a system failure. Correction, you corrected something, but you failed to correct it in the perfect manner. So it left still an opportunity for error and opportunity for accidents. Standards, if the standards are, again, defective. So if you say, all right, we're going to excavate up to 5 feet, I don't need any support. That's the standard. But maybe that standard needs revision, because again, with this type of soil, you would need the support. We're going to learn about that when we discuss subchapter P, which deals with excavation. So again, systems failure, all of these would result in an accident. So whether it's overload or ergonomic traps or decision to err, which all of these are human errors, or it could be a systems error or system failure, all of these are going to lead to accidents, and the accidents are going to result in injury or damage. Injury, personal injury, or damage to property, or both. Another theory is called the Epidemiological Theory, long word, Epidemiological Theory, which deals again with propagated behavior that becomes like an epidemic. So what does the Epidemiological Theory say? There could be some predisposition characteristics, like susceptibility of people. Some people, you can describe them in general as clumsy. They're not very good with the hand-eye coordination, or they don't have quick reflexes and things like that. Perceptions. Again, perceptions, you might perceive something like as easy or simple, while it could be hard. You might perceive that this block, this CMU block, is light. It's not that heavy. And when you try to lift it, it would cause a back spasm or a back injury. And environmental forces. Okay, when we do this task, usually on a clear day, we have no problem. But today the weather is a little bit foggy. You may have heard about that accident that happened on January 17th in London. There was a helicopter that hit a crane. The helicopter was flying low, and it hit a crane, and it crashed and burned and killed 2 people. Well, the pilot of that helicopter was a very skilled pilot. The problem was that it was a very foggy day, and he was not supposed to fly at this low altitude, and so on. But it happened. So this is an environmental force. Another issue is situational characteristics, which might occur on the spot, like risk assessment by individuals, as we mentioned, and we're repeating that example again because it happens quite often, that this siren, reverse siren in a truck, it's too noisy, I'm going to disable it. So you disable it and you're backing up, and someone is standing behind, did not hear the siren, so you hit them. Or again, it's very hot today and the hard hat is increasing that feeling of heat, so I'm going to take my hard hat off. Or I'm sweating too much and I can't see through these goggles, I'm going to take the goggles off. Or I'm working on, again, a high platform and I can't move freely with that harness, so I'm going to take it off. This is a bad risk assessment by the individuals. Peer pressure. And this is a very common cause of problems on site, with people challenging each other or daring each other, pressuring each other to do something that they wouldn't normally do under normal conditions. Priorities of supervisor. We are behind schedule. We need to achieve more, so we're going to cut corners. Again, nothing should replace safety as the top priority. Not time, not quality, and not cost. And then attitude. Again, I am too good for this thing to happen to me. I am indestructible. I have done this in the past, so I'm not going to listen to the instructions. All of these are epidemiological problems that can spread very easily on site, and that's why you have to pay attention so that this behavior does not get repeated. Otherwise, it's going to be a major problem on site. Again, all of that can cause or prevent, if you pay attention to it, it can prevent accidents from happening. If you don't pay attention, it might result in accidents happening. In the systems theory of causation, the root cause could be a person, a machine, environment. Any of these, the interaction between these can cause a problem. So you need to collect information to try to avoid this problem from happening. What would happen if we operate this man lift close to power lines? Is this power line activated or not? What if we use that scaffold and we move the scaffold, which has wheels, while someone is standing on top of it, and so on? So collect information about what you can do and what you can't do. Weigh risks. Again, there's no project without risks. There's no activity that's risk-free. All we're trying to do is reduce the amount of risk and its likelihood and its impact as much as possible. But we are never going to have a risk-free environment. It's just a matter of knowing what the risks are, calculating them, and knowing how to deal with them. So weigh the risks, make decision based on the information that was collected and based on that risk prioritization and its weight and its impact and its probability of happening. And finally, define the task to be performed or design the task to be performed based on this educated process. Information to be collected includes job requirements, workers' abilities and limitations. So, for example, if you have asthma, for example, you should not work in an environment where you might be subject to toxic fumes or lack of oxygen or something like that. What would be the gain if the task is successfully completed, and what would be the loss if the task is attempted but fails? Loss in human life or injuries or in property damage as well. And what is the loss if the task is not attempted at all? So all of this kind of information needs to be collected before designing the task to be performed. Finally, behavior theory, the BBS. There are 7 basic principles to the behavior-based safety theory. Use intervention that's based on employee behavior. So you're going to monitor your employees and see what are the pitfalls, what are the common mistakes, and tailor your program to take care of these mistakes so they don't happen. Identify external factors that aid in understanding and improving employee behavior. So how can you motivate them? How can you encourage them? How can you, in some cases, the carrot and the sticks. So in some cases the carrot might work, in some other cases the stick might work. Direct behavior with activators or events antecedent or prior to the desired behavior, and motivate employees to behave as desired with incentives and rewards that follow the desired behavior. So we're going to say, for example, we're going to have a meeting, safety meeting on site. We need to finish this project with 0 accidents. So everyone is going to be paying attention to that. We want to have an accident-free site. And if we manage to do so this is the antecedent to the action. And then you would say, if we manage to have an accident-free project, every employee is going to get a reward of such and such type. Whether it's going to be free days, whether it's going to be extra payment, whether it's going to be extra benefits, whatever it might be, something to encourage them to have that accident-free project. Focus on the positive consequences that result from the desired behavior as a way to motivate employees. You can say, for example, if we manage to finish this project on site, first of all, top management is going to look at us very favorably. That's going to improve the profitability of the company. It's going to improve the competitiveness of the company. It's going to reduce the cost to insurance for the company, which is going to reflect on the employees of that company, giving them better opportunities and so on. So this is a positive enforcement of a good behavior that might result in less accidents. Apply scientific methods to improve attempts at behavioral intervention. So again, when should encouragement work and when should penalties work, and on which people? Again, in some cases you want to set an example so that a bad behavior would not be repeated. Use theory to integrate information rather than to limit possibilities. Again, remember in the previous slide we thought about one of the questions to be asked: what would we lose if the task is not done at all? Sometimes you have to do the task. It's part of the scope of the project. Therefore, the idea of the task not being done is not acceptable. So we're going to use the theory. Okay, since we're going to be doing it, how can we do it in the most safe fashion, following all of these precautions and following all of these steps at trying to change the behavior of the performance of this task so that we can finish it without any accidents. And finally, plan interventions with the feelings and attitudes of the individual employee in mind. So if you have an employee who's down today, for example, due to job-related stresses or domestic stresses or whatever, try to encourage them, try to talk to them, try to get them out of that mood of depression, because that might result again in absent-mindedness, which usually leads to accidents and injuries on site. So we're going to have activators that lead to behavior. You activate people through encouragement, through incentives, etc. That leads to a better behavior, that leads to better consequences, which is basically not having any accidents, which might lead to outcomes. The outcome is the project is accident-free, everyone gets a reward, and the company performs better and gets better recognition. Hazardous operation management. Basically, we're going to think about how to select a method and then apply that method that's safe. Monitor and observe while the action is taking place to make sure that what the method that you selected was effective in reducing the probability of accidents happening, and assess that effectiveness. We were successful by 95% or 98% of the time. This results in no accidents. So what about the 2%? Should there be any corrective action for this extra 2%? And finally, adjust as necessary. Maybe this 2% was primarily personal issues. These people should not have been there in the first place. So next time we plan this operation again, we're going to avoid having people of that type who did not properly have the training or have prior health problems or something like that. We're going to avoid having them on this operation so that we can finish it with 100% risk-free or accident-free fashion. So this basically is our lecture about accident, the different theories of accident causation. You should learn about these because these are going to have an impact on how to motivate, encourage, and delegate to people on site so that you can have minimum amount of incidents or accidents resulting in bodily damage or in property damage. I will see you in another safety lecture.